All right. So again, thank you very much for inviting me to deliver this talk about competent modeling. I will give you a brief introduction and hopefully I can manage to leave some time for questions or discussion by the end of my talk. So competent modeling is a scientific posture that is making use of agent-based models and also role-playing games. I will try to explain about the tools that we are using, but first, let me tell you a few words about the principles and from where this scientific posture is coming. You have to know that we call it COMMOD because in English it's component modeling. So we built an acronym from component modeling. And now the network is known as a COMMOD network. So component modeling is a branch of participatory modeling. We really stress the importance of seeing the participatory modeling process as an interactive process. It means that most of the time we are going to develop not only a single but a family of more or less related models that are made to support the dialogue, shared learning or collective learning, collective decision making. I will maybe provide you some more details about what we can put behind all this. There is a generic term, social learning, also that we use often to characterize what we try to promote by co-designing and using agent-based models with local stakeholders, local actors. So this is a really key point that who is driving the process are the stakeholders and not the scientists. So it means that we are not completely sure that the ending point of the process will be what we envision at first. This is also one of the reasons to call this approach companion modeling. So we go with the local stakeholders and depending on the burning issues that may change over time, we can switch from one objective of the modeling process to another one on the way, on the fly. Right. So the drawing is just to illustrate this idea that obviously we have this iterative process of looping where from the lab we go into the field and we build the first version of a prototype model, and then we can refine the question. But if it's always related to the initial issue, we have a first stage of the process, like on the left side in blue. Let's say we have a first modeling process, and when we reach a point, it may change the direction. The participants of the process also can change over time. The group composition, we may have some new people joining, some others leaving, and depending on the new question, a related process will take over. And it can continue like that for processes that are quite long. We have examples of processes that lasted for like 10 years, but it's not always as long as 10 years, of course. One other key characteristic of component modeling is the fact that we try to accommodate not only one objective, one main objective, but we always have two objectives in mind. The first one is a very classical one, is to produce knowledge by designing and using models. And we are working on socio-ecological systems, so kind of complex adaptive systems, and also contested systems most of the time, where you have stakeholders who have very different objectives in mind. So it is forming what we can also call wicked problems, where we don't exactly know how to formulate the problem. And in this kind of very complicated situation, designing and using models can be seen as a strategy just to produce knowledge on these complex adaptive systems. At the same time, we also have the objective to do action research. So here the idea is to support and to improve collective decision-making and a key natural resource management or land management problem. In practice, both objectives are often implemented simultaneously, but of course, it's easier to put one on top of the other. So just to make sure that you can prioritize the choices of the modeling process according to the main objective of your process. The component modeling network exists for more than 20 years now. At the beginning of the years 2000, we collectively wrote what is called a charter, where the main principles of the component modeling have been formulated. It has been published in JAS, and here you have the main points of this charter. So the scientist is one among other stakeholders that can provide some ideas about the content of the model, but we try to take equal account of all involved stakeholders and to incorporate knowledge of all the stakeholders into the model. So the model is really something that is receiving the representations and the specific perceptions of the problem from the different participants. We try to be transparent. So the idea here is that we must be explicit and we must discuss not only the scientists among themselves, but all the participants to reach an agreement on what to incorporate, to integrate into the model and what to leave out of it. We try to be iterative and adaptive, very classical for any modeling process, and try also to discuss about the outcome of the simulations. But for us, the evaluation of the process is not only directly linked to what the simulation model can produce, but we also discuss about along the process, what happened along the process, and the social learning is really coming from the interactions among the participants, much more than from the outcomes of the simulation model. So here we have a diagram to illustrate the process. So as I already mentioned, we are focusing on socio-ecological systems. So we see them as something between interactions between a society and a natural environment and people using resources. So we have users of natural resources, each one of them with a specific representation, with specific objectives of using resources from this landscape. And we create an arena from these stakeholders. We engage some representative from each group of stakeholders into modeling group. And the idea is to build a simplified representation of the social ecosystem. So it's really the first phase is a co-design of a simplified representation of the socio-ecological system. And working together, stakeholders and researchers, to co-design this model, we will learn. And when a first version of the prototype model is ready, we will use it. And by using it, discussing the result of the simulation, the learning will continue on another level. And eventually, what we seek is to produce some changes among the participants in terms of new knowledge, evolving perceptions. Maybe sometimes it may happen that some of the participants will change their behaviors or practices as a result of having participated to the process. So what we call social learning is something that is quite complex also, or at least multidimensional. I've put here a classification of the different aspects that we can reach by involving people in a component modeling process. Of course, we can produce things that are related to knowledge, cognitive aspects, and better understanding of the way the system is functioning. But because we are working in collectives, in groups, also the relational aspects are very important. Mutual understanding of the different perceptions of different stakeholders are something that is really a key starting point if you want to build a consensus, if you want to mitigate conflict among participants. You really have to do something about the relational aspects, and being involved in a participatory modeling process is something that is functioning very well. And we can also touch normative aspects, like we can better understand the motivations, the values, the beliefs of the different participants. And also this dimension is sometimes very, very interesting to tackle. I will stop here for the very brief introduction of the network itself, saying that we have produced collectively some documentation, a book that was published in 2010 and an English version a few years later in Springer editor. And we have also methodological guidelines for the whole process of a component modeling, but also for some specific stages of the process, like designing a conceptual model. One researcher from INRAE, Michel Etienne, proposed specific methods to design collectively a conceptual model of socio-ecological system. It is called RD. We also have collectively produced manuals for the observation and evaluation of the process, and particularly of serious games session. And also we propose training sessions, researcher school, to teach about the component modeling process. And you can find many information on a website. You have the URL and the title of this slide. Now I will maybe say a few words about the connection between component modeling and agent-based models, because I believe during your GAMA days you have a lot of presentation of agent-based models. So the topic of the models we design in component modeling are, most of the time, we can refer to relationships between humans about the use of natural resources. Of course, from this drawing taken from Jacques Ferber, which are the main principle of what is an agent-based system or multi-agent system, all the principles will work quite well if you apply multi-agent systems to a socio-ecological system. What is key or very important to us is to work with 3 levels of interactions. Of course, interactions among individuals, interactions mediated through the sharing of the same environment, but also interactions related to the fact that some of the individuals may belong to some institution or groups or syndicates or any kind of groups of individual actors. So we try to tackle these 3 levels of interactions into the agent-based model we design. I will skip these 2 slides because they are very, very classical ones, and I'm quite sure most of you know very well about the principle of agent-based modelings. So our agents will be computer agents that will follow these properties or features: autonomy, social ability, reactivity, proactivity. They will be equipped with some possibility to perceive the environment, to do, to act, to perform, to memorize or not to memorize the previous states, and to make their decision based on their past experience, and to set decision. To set decisions, this is where we will have an idea that sometimes it's quite difficult to specify the decision-making processes of the stakeholders. For that, you can do surveys, interviews, and try to capture the criteria used by the local actors to make decisions. But sometimes it's so complicated that you will spend a lot of time and not end up with something that is very satisfying. So the strategy is to leave this open and to have participants of the interactive simulation workshop to make themselves the decision. And so the decisions will still be human and not artificial. And this is where we can talk about hybrid participatory agent-based simulation. This is why we are using role-playing games in combination with autonomous agent-based simulation in COMMOD. And we have different ways to combine these two different tools. What is really key is to promote interactivity between the participants. Here I have a slide just to show you that there is a continuum of situation from to the left where you don't have any artificial decision in your model. All the decisions are made by human participants. This is a non-computer role-playing game or serious game. And to the other extreme on the right side, you don't have any human decisions when you have fully autonomous agent-based simulation. So we can have composite agents. Some of the decisions will be made automatically by an algorithm, but the key decision you would like to focus on will remain into the hands of the participants, human participants. And in companion modeling application, we have several situations. Altogether, I think this combination of role-playing games or serious games and autonomous agent-based simulation is a fruitful combination to engage local actors, local stakeholders into anticipation. This is by combining these kind of tools, we can put participants into situations where they will face changes, and we will observe how during the workshops, the participants will react to the changes we will have them to face. And then we can specify with them some kind of decision-making processes that are validated through these interactive simulation workshops. And finally, we can draw autonomous agent-based simulation and explore in a longer term scenarios for 20, 50 years that you cannot do if you only use role-playing games. So it's really a fruitful combination of these two kind of tools. I think you will have during the GAMA days a session on serious games. So you will have examples, I think tomorrow, is it tomorrow? That you will have examples of games, serious games during the GAMA days. And I don't know how many time I still have. Is it okay for a few minutes more? Then
yeah,
I
just
can...
a few minutes if you have to ask some questions.
Okay, right. Oh, I just wanted to illustrate by two examples in Africa, this combination of role-playing games and agent-based simulation. Here, it's an example in Senegal, where you see local actors who are farmers. Some of them are more livestock breeders, and some other are more rice farmers. And the issue is a conflict on the use of land in this northern part of Senegal. It was at the beginning of the years 2000 that we designed a model starting from role-playing game. You can see the board game on the wall behind in this picture. And in the at the front of the picture, you see people discussing, pointing or looking at the screen of an agent-based simulation. So the process was to first start by a role-playing game session where people discuss about management rules to mitigate the conflicts between agriculture and livestock farmers. And then we also had a similar tool with really the same representation of the landscape. The different colors are coding for the types of soil, and in blue you have the water points. And so it's about the conflicts between farmers and the animals of the livestock breeders. And at some stage, the participants of the workshop discussed about the possibility to build canals to reduce the occurrence of conflicts. And bon, it was one of the discussions we had during the workshops. And you can see here another pictures with the people looking at the computer simulation. And we explore several scenarios with the addition of canals to provide more water. And one output of this process was that 10 years later, these canals that were discussed 10 years before during the workshop actually were built in the reality. Another example in Senegal, just to show you maybe the kind of stylized representation of the landscape. Here it's about the cattle management at the border of a protected area. And we had a process to co-design with a group of local farmers, a representation of the environment. On the left side here, you have the communal land with some fields and people doing some farming. And on the right-hand side of the landscape, you have a forest, a protected area. And at some moment during the year, the farmers, they just go with their animals into the forest, which is forbidden normally, because they don't have enough food for the animals in the communal lands. And so we designed a model to discuss about this. First, we started with a group of local farmers. We had a first version. We used by that time not the laptop screen, which was not very convenient, as you may have seen in the Senegal example. Here we use projector to have a game board that is a virtual game board, but we still have the possibility, the opportunity to use tokens and to have people interact on a digital game board. And finally, we invite other stakeholders in the second stage of the process to promote dialogue between the local farmers and the responsible of the protected area and the rangers from the national park. And this is to promote dialogue and to engage discussion and negotiation between the different stakeholders. So here we observe what is happening during the opening game sessions and who is taking the decision to decide to go and to discuss with the other players. So the way we have the setting of the participatory simulation workshop is also thought so that we can observe initiatives taken during the workshop by the different participants. That's it for the take-home message of my presentation. What are the benefits, or what is the usefulness of having this kind of participatory interactive simulation workshops? First, it helps participants to understand how the model works, because the participants, they will face directly the effects of what they suggest, and they will better understand. It also stimulates participants to move away from their specific personal situation. Sometimes it's difficult when you discuss with local actors, local stakeholders, to have them engage into a specification of a model being a kind of stylized representation of their reality. They really stick on their personal features and what is important for them in their real life. And it's difficult to have them becoming a modeler. But having this kind of very simple stylized models, it's working quite well because then they can engage into the collective process of helping you to specify the essence of their activities. And they are the best places to provide you information, good information about the criteria they use to make their decision. It's also a good strategy for engaging these local actors into the group of modelers, and they feel like the model is theirs because they were engaged from the beginning of the process. Okay, I stop here. I hope
Yep.
I did
Perfect.
not use all of my time.
No, it's okay.
Thank
We
you for
have
your
time
attention.
for a few questions. Thank you very much for the presentation. It was very interesting. So we have a first question from Franck about do you have example of use of models directly by stakeholders without scientists, playing games without the scientist after?
That's a good question. The truth is that most of the time when the scientists are not present anymore in the site, because that's the end of a project and the scientists are going to work on other projects. Most of the time, the people are not autonomous to use the tool without the support of a scientist. So I really don't have an example to provide where this could have happened. But maybe some other colleagues have example of that.
Okay, after we can discuss about that later. We have a question from Kevin, but it's a bit long, so I will let Kevin ask his question directly. If it's
thank you, Patrick. Thank you, Christophe, for your presentation. So the question I wrote is quite long, but in short is like, what is the reach of COMMOD? I mean, in terms of number of actors and etc. Because you only are focusing on few actors, and how you grow the result. So the social learning can be at the stage of the system itself, not just few actors of the system.
Yeah. So I think maybe I can mention that there are two directions, maybe to expand the effects of a classical COMMOD approach, which is, you are completely right, mainly implemented at the local level with a group of people that is reduced to 10 to 20 participants. So you can either outscale your COMMOD process, meaning you will replicate several times these kind of local workshops. But for that, we need to work jointly with other people than scientists. So it has been the case, for example, in several COMMOD projects where there is a kind of first phase where the scientist is involved to create the main tools that will be used later on, and to train the people that will use these tools to replicate the workshops many times. So it happened with the Lizard, which is an institution of here in Montpellier, in France, where people are the members of the Lizard organization are used to organize workshops with agent-based simulation and role-playing games, and they can replicate tens or 50 times the same workshop. So this is a strategy of outscaling. Another strategy would be upscaling, so trying to reach the highest level decision makers and organize workshops at the level of the policymakers, provincial level, regional level, national levels, international levels. That's another strategy. And I think we have example of COMMOD processes that have been implemented at that level. This is not my case. I don't have any experience in that. But I have other colleagues, like, for instance, Claude Garcia in Switzerland, who is used to organize this kind of processes at higher levels.
So, yep, thank you very much, Christophe. We have other questions in the chat, but we unfortunately don't have the time. But if you can answer the question in the chat, it can be perfect. Sorry, and thank you very much again for your presentation and the answer of the questions. But we have to move on to the next presentation of it will be Cédric.
Okay, so today I'm going to present the project of Léia SAVARY. She is sick, but she's in the chat. So if I make mistakes, she will be able to tell you that I'm making some. And she also will be able to answer if you have questions in particular, if you have questions to which I cannot answer myself. Her project is about modeling crisis management scenarios, simulating behaviors in case of marine flooding. So it's a PhD thesis that is supervised by Mohamed MAANAN, who is a geographer, and which is co-supervised by myself and Pierre, who is also a geographer. Sorry. Yeah. So we focus on two communities. The first one is Bat-sur-Mer. So these two communities are in the Pays de Loire, in the west of France. And the first one is Bat-sur-Mer, and the second one is l'Aiguillon-sur-Mer. So these two communities, l'Aiguillon-la-Presqu'île. These two communities share some commonalities. They are both on the west coast, and they are both at risk. I will show you for the Bat-sur-Mer some simulation later on. And l'Aiguillon-la-Presqu'île has already lived marine flooding. I will show you also a photo a bit later. But they also have some differences. The geography is pretty different, as you can see. The blue part on the bottom two images are the parts that can be flooded and that are at risk. And as you can see, there is a difference in the topology of these two places, and there is also a difference in the way we can access it. So here you have two videos of Bat-sur-Mer. At the west, you can see the effect of Xynthia, which was marine flooding in l'Aiguillon-la-Presqu'île. So it's the same flooding as what happened in l'Aiguillon-la-Presqu'île. And in the right part, you have the same flooding, but with the predictions of our IPCC, because in the Pays de la Loire, we have a regional IPCC, which made some provisions for 2100. So as you can see on the left, there already are some impacts on the habitations, but on the right, you can see that there are much more impacts. And moreover, there are also impacts on the roads, which will be pretty interesting for our use case when we will be talking about multi-agent simulation. So there are actually several kinds of risks. There are natural hazards and industrial hazards. Here we will focus on marine flooding, but our work can apply to several other kinds of hazards, including industrial hazards, and we hope that we will be able to apply the same approach to other kinds of hazards. So here you can see our approach. On the left, you have the vulnerability of issues. So you can see, for instance, issues regarding infrastructure like building, roadway, and also protective infrastructure when they exist. You also have, in the specific case of flooding, the issues regarding altitude, and you have issues regarding the population, more specifically, the location where a population is. And on the right part, you can see vulnerability related to individuals. So here we actually work on the modeling of behaviors. So you can see that there is some part which is related to risk awareness. So are people aware that they live on a territory that is aware of the risk? So here, actually, there is a real difference between Bas-sur-Mer and L'Aiguillon-la-Presqu'île, because Bas-sur-Mer has never known a marine flooding episode, while L'Aiguillon-la-Presqu'île has known such episodes. And there are also other parameters, one of which is the behavioral parameter related to reaction, social capacity, and so on. There is also some parameters related to physical conditions like age, height, weight, and also physical capacity. And finally, some parameters which are related to lifestyle habits. So actually, this right part will be used to how to say it, to feed our model agents. It will help build the behaviors of the agents in our multi-agent system. And moreover, we will add to that traffic problems and traffic jams, and GAMA will be of much help for this part. So the idea will be to have like some a left part with issues and cartography, and also the flooding itself. As we will see, we have already begun modeling the flooding. And on the right part, the behavior, and which is deduced from some questionnaires and interviews with people on site. This will feed our multi-agent model, and finally, it should be used for a mobile crisis management application. We have a partnership with the firemen in the West Coast. So we have developed our multi-agent simulation on GAMA. We have several entities, several agents. The first one is the cell, which represents the terrain, and we have like a default water level and elevation. And the water level will higher, and when it's above the elevation of the terrain, the cell is considered as flooded. We have buildings with several functions like a house, school, work, and so on and so forth, and a submerged state. We have roads, which are also imported from geographical data, and with a submerged state, which something is quite important here, because when a road is submerged, agents cannot move on this road anymore. We have intersections, which are created from the geographical data also. And we finally have people. So these are the most complex agents. They have a routine in the environment, like going to work, going to school to let children in school, going back, going to the shop, and so on. And we also have cars that are able to transport people. We also are working on the analysis of territory. So we have the mapping of issues, which are deduced from this left part with the issues related to infrastructure, altitude, and populations, and so on. And the multi-agent system will also be used to improve this map, depending on how the submersion impacts the different parts of the map. And we are also working on some mathematical tools in order to have a good evaluation of this risk. So here you have, oops, sorry, wrong one. Here you have the gamma simulation. So this is the first simulation we made. Here you have the agents moving. As you can see, there is no submersion. So this is when they follow their habits. And on the left part, you can see that there is a submersion going on. And as soon as the submersion raises to some roads or buildings, they are coloring. And as you will see, when a road is impacted, all the cars are blocked. And when the cars are impacted, they are noted as flooded. So for the moment, the cars have a very simple behavior because they try to keep following their path. But we hope to be able to create a more complex behavior where agents try to change their path when they meet a submersion. And finally, well, I talked before about behaviors. So for the moment, we have identified 4 kinds of behaviors: seniors, families with children, people with reduced mobility, and people in good health. And we are expecting those people to have different kinds of behaviors and to sometimes evacuate when they have the information beforehand. And they also may stay if they have some knowledge and they think they can handle the submersion, or they could also stay and panic. And in which case we have several kinds of responses. They can phone to the assistance. They can ask for emergency. And as I said, we are currently talking with firemen. There are several kinds of plans, and they also have their own model to evaluate the risk in the territory. So we work with them to see what are the priority when there is a submersion. So that's it. There is the email address of Léia SAVARY right here, but she's also in the chat. And thank you very much for your attention. If you have questions, as I said, Léia can answer, but I can also maybe answer if it's not a too complicated question.
Thank you very much for the presentation. We don't have much time, but we can have time for questions. First one, do you model also multi-risk? I see from Franck Taillandier. Interaction between hazard and yep, such as NATEC scenario. So not maybe you know what is it. And do you consider emergency services? Yep.
So our goal is to be able to consider emergency service during the crisis. And that's also one reason we contacted the firemen. Regarding multi-risk, actually, it would be interesting because in particular in Bas-sur-Mer, some of the zones that are the most at risk are industrial zones. But for the moment, we are not working on that. We have like cascading effects, but for the moment, we are not working on that. It's not our main focus right now.
Okay, just the last question before, because we don't have much time. How do you generate your population of agents? Are you using specific methods? Because there is some specific method to generate the population from census data and stuff like this, or how do you generate?
Maybe I can let Léia answer. My answer is that we know the global population of each of the towns. So, and we also know which part of the towns are homes and which part of the town are related to shops and work and so on. We have this typology of buildings. So we are generating people in house buildings, and regarding the way they move, this is also why we have questionnaires, and why we ask people directly in place.
Okay, thank you very much. Yeah. So maybe we can pass to the next presentation. Thank you again for your presentation, for the answer, and we pass to the next presentation of Zenith.
Good afternoon, everyone. So I'm Zenith Arnejo. I'm currently based in Toulouse, and I'll be presenting my work on trying to make ABM more transparent and communicable to general users or stakeholders. So specifically, I'll present a methodology for visualizing ABM process flows using simulation traces. So this presentation is divided into 5 parts, whereby I will present the methodology right after the introduction, and then try to present it given 2 models available in GAMA platform. But I use it in my case study, which I will present tomorrow. And then I also will present some results on the testing I did with some stakeholders, and then some student stakeholders then conclude after that. So one of the most pervasive challenges with the agent-based modeling paradigm is its resemblance to a black box system. This is real hindrance to effectively communicating model structure and outcomes to stakeholders or other interested parties. In the literature, the standard approach to opening the black box involves providing thorough model documentation and ensuring open access to models' source code. These 2 methods directly address the issue of model transparency, which is generally defined as a system's property that reveals how a model operates or functions internally. However, relying solely on model documentation has several drawbacks. Documentation styles can vary widely, often lacking consistency, and sometimes introducing bias. Additionally, documentation can be overly lengthy. While open access to source code provides the most transparent and detailed insight into the model, it is not always ideal for all stakeholders. Understanding the code often requires a significant investment of time and effort, which may be impractical for those without much technical expertise. So therefore, we aim to explore a balanced approach to model communication by developing a visualization tool. The goal is to provide a view of the model closely aligned with its source code, but yet independent and not derived from its documentation. So as such, I'd like to present the methodology. So we present a 3-step methodology to extract and visualize ABM processes. The first step is through simulation logging. This takes place during model execution, so you don't have to really change anything about the model code. There's just a logging that's happening at the background. So after obtaining the logs, the second step is automated process discovery, which will extract the ABM processes. Finally, the discovered processes is used in the third step, which is mainly about rendering these processes in a visual form. So for the first phase, we gathered simulation logs during execution. So logging is triggered when there is any modification to the agent's attribute or when the agent performs a different behavior. Change is determined based on the content of the current execution tree or the statement passed in the execution scope. So looking at the example log file, I collect basically just 5 information: the case ID or the simulation cycle, the activity or the function, behavior, action, reflex that is executed, timestamp, this is just for the chronological ordering, resource is the variable that changed, and value is the current value. So I just log the value in case I can do something with this value and get some insights on the input, output, and what happened in between. So, but at the moment, I didn't really use the value. So after that, I fed the log to DoublePower's automated process discovery, which will utilize the directly follows graph algorithm to obtain a process map given an event log. So you have the CSV log file, and then it will be converted into an event log. And then using the DFG algorithm, it will determine a process map. So since resulting process map could be very large, I added a filtering layer to remove some edges that are not really very significant. And I also removed self-loops. So the nil arrows here you can see in the CSV files are cleaned or removed before obtaining the process map. So I converted the process map into a business process diagram using a meta model, the OpenBPM meta model, in order to better visualize the process and provide emphasis on the species that executed those processes. The goal is to have a better view on the agents that interacted and how they interacted. So you have this process map, you just directly convert it into a BP diagram. And then you can see there the two lanes. So basically, this lane is for the main process model, and this one is for the species people. Okay, so this is from this process map. So from pool of available BPMN elements, I only use 4 types to have a simple diagram. So I have activities or tasks used to specify the action executed or the variable changed. And then I also have the sequence flow for the connection or edges, and the swim lanes to organize the process by executing species. So very similar to BPMN is the widely known UML state charts. So we know that. So to have a basic understanding of BPMN, let's look briefly on the two. So while UML state charts track the states of individual objects, so in my example, this is creating issues in a project management tool. So I have specifically there the states of the issue, open, in progress, waiting, and done. So in BPMN, we have a comprehensive end-to-end view of the entire process of creating an issue. Plus, there could be an integrated multiple components to have a complete workflow. So that's why in the visualization, you don't only see the species declared in the source code. You can also see the internal setup of the platform that interacts with the execution of the model. This broad perspective is a key reason why we have chosen BPMN for our visualization. So aside from the visualization, it's also possible to automatically generate a text summary. This is to have a reference, especially when there's a lot of arrows or connection between tasks or reflexes that is very hard to follow. Aside from that, it is also possible to automatically isolate the lanes to have a focused view of the dynamics within a species. So in this particular example, I use the segregation model. So just a simple toy model from the GAMA platform. So to see it more in action, at the moment, this tool can be used on any model created in the GAMA platform, but I believe it can be easily done on other platforms. You just need to have the simulation trace, which is just you have to look at some and add some plugins anyhow. To show some examples, I'll present how the visualization looks like given 2 toy models, ant foraging and lunar flu. So the first toy model is ant foraging. So here we have ants as the main agent, and then it performs 2 actions, forage and return. We also have sites where the food is found, which serves as the target of the ants. So how does it look like? So I run exhaustive exploration and gathered simulation logs during execution. So here on the right, we can see the visualization of the variables that change during the execution. So this is the overall view of how the process worked. So I logged and then I merged those logs, and then I have this as a summary of what happened. So this is the variables in the model, focusing on those. So referring to its source code, we can have a visual view on how the model executes. The variables inside ant model refers to those that are globally declared and are created automatically by the simulation platform. In the ant lane, we can see 4 main variables. Has food, we can see it clearly declared at the start of the species declaration. Then we have the state, which was actually created because of the use of the finite state machine in the model. And then the current edge and current path from the skills moving. So basically, there's 4 main variables that are really being changed during the execution of the model. So to clarify the connection, it is best to refer to the text summary of the visualization, but I will not go into detail of that. So in terms of the action, if we reflect this, we can see that the behaviors are strongly connected. You can see from the visualization. And we can also identify which are the most important ones during the execution. We can see that the model executions begin with the diffuse function here, and then calls the diffuse road, which is, over there. And reflects of the ant, and then proceeds to drop pheromones, follow road, wander around, pick or carry food, and then return. So you now have a general overview of what really happened during the simulation without having to really go through the code and to see how it passes through different functions. So another example, just for us to be acclimatized on this. So this is the lunar flu model. So it is a simple flu spreading model where the main agents are people moving in the environment with constant speed and can be infected or infect along the way. So based on the short documentation, so here we have the short documentation. A model was developed. So this is the one on the left side, on the middle. And then we have the visualization showing the connection between the actions and how we can expect them to move from one behavior to another. Note that the visualization is obtained from the simulation logs. So it's another view, a more transparent view of how the model works. If you just want a clearer view, you can look at the corresponding textual summary of that. The simulation log was collected during the calibration of the model. So we can find here a lot of variables not explicitly present in the source code, but are actually part of the simulation plan of the simulation. Example is the RNG usage for random number generation, the duration, total duration, average duration, which was actually signals that used during calibration. Most important ones, maybe we can see the variable road network and the infected and the number of infected people. So we can have an idea of the main important variables in there. So for this lane, we can see the variables that are relevant to the execution of the people species. Since this species utilizes the moving skills, we can see current edge and current path all linked to the variable target, which is actually a point in the environment where the people intends to go to. And then there's this is infected variable that is updated at each move. Connected to the end node in this case only means that the execution of the people agent can end after updating the target, current edge, or is infected variable. So if you refer to the code, you can see there that the target could be nil, so it ends now, and then it could stay on the place where it is currently at, and it could end the execution of the cycle at that point. So to test the usability of the visualization, I conducted some testing with student stakeholders. So since the visualization is more intended to teach what's going on without having to really look at the code. So it's a complementary visualization. So I had in total 9 students who signed up for the hands-on workshop. So I gave a short overview and then presented the segregation model with them. I let them explore and use the visualization, and then I asked them to fill out some of the evaluation form at the end to see if it helped or it allowed them to have some jump start in understanding agent-based model. So here are some of the results. So in general, the students were positive in the usability, but the scores on the negative phrase showed that the visualization needs to be improved. So I did it in April this year, so the visualization is very much different from the one I presented because those are just some of the improvements I added along the way. So to conclude, this tool aims to contribute to 3 modeling aspects. So in model verification, especially with complex interacting agents, the tool can provide a jumpstart to understanding how processes inside the model are interacting and what are the actions or variables that constitute the model. So in model documentation, this could be a starting point in creating or supplying the documentation of your model. In model communication, this is targeted for those with limited technical background as a starting point also for understanding what the model is about. So it's for students, stakeholders, and general users. Future works involve using the visualization with more stakeholders to have more feedback and also to eventually make it available to all who are interested to use this visualization. So yeah, so it was just a quick presentation, and thank you for listening. If you have questions.
Thank you very much for your presentation. I don't know if you have questions, so I don't see any question in the chat for the moment. So if you have a question, you can write your questions. For me, just to have an idea of the target user of your tools, because you tested with students, but it was students in computer science that already know about UML diagram, the GAMA and so on. Is it usable stakeholders that have no knowledge at all with GAMA and modeling and so on?
My audience was actually mixed. So there are some undergraduate computer science, master's computer science, master's foresters. So there are some that doesn't have any computer programming background. So what I use with them is the toy model and the forestry model that I created. So the feedback is actually mixed. So for those who doesn't have programming background, they really have a hard time looking at the code. But with the model simulation and the visualization, they had an idea on what's happening in the model. So the model, the visualization aided them to understand, oh, this is what's going on inside the model. So basically, that was the target user.
And is it usable with complex model? Because, for instance, here you just show example with a very simple model, but for more complex model, is it still usable, or the GAM is too big to be understandable anymore?
So I used it in my case study. I have around 6 agents and a couple of number of instances of those agents. So the big picture is really big. Complete visualization is really big, but then you can isolate the lanes and see better what's happening in the species. So that's what what could be helpful. So though it's really big, but you can isolate the main species and then you can have an idea, oh, this is what's happening in this particular species.
Okay, thank you very much. We have to move on to the next presentation because we are short of time, but thank you very much again for your presentation. And so we are going to go to the next presentation by Kevin Chapuis.
Okay, so don't need to present myself as I was here this morning for a presentation. So here it will be about a serious game that we build with GAMA called SimSwitch. So this is part of a 9R project, a French project called Switch, where there's always two type of outcome, let's say. The first one is a board game called MobiSwitch, which will be available to sell in the near future. And there's also a simulator powered with GAMA, of course. So this is the two main outcome of the project. And here we'll be talking about a third outcome of the project, which is a video game or a serious game, let's say. So the objective here is to, of course, raise awareness about transition towards sustainable mobility, urban sustainable mobility, which is the topic of the project and the two previous outcome. But the main objective, let's say, is to collect data on decision making. Why people are turning to bicycle, for instance. Why they turn to public transport, etc., etc. So the idea was to collect a bunch of data on barriers toward those changes in mobility, and among them, the cognitive barriers was the first we targeted, and there's two models made by Carole Adam that focus on two cognitive bias, let's say, in using net logo models. I won't go into the details, but here we want to enlarge the scope of this serious game to also include political, socio-economical, and practical barriers. So to speak about those difficulties toward the transition to sustainable urban mobility, so I told about the cognitive biases. For instance, we are looking for habits, how people can change their habits, or how people will follow the others, so the social norm. And we do also represent few cognitive biases like halo or reactance biases. So there's, of course, political difficulties, and one of them is that infrastructure do not drive the changes most of the time. This is not because you build a road for bicycle that you will have more people taking the bicycle to go to work. So this is one difficulty towards the transition. And of course, there's practical difficulties like accessibility. We know that people far from the downtown, for practical reason, they will use their car, etc., etc. And behind this notion of accessibility, there's also the question and issue of just transition towards sustainable mobility. I go a bit fast here so we can discuss about the GAMA topic in this game. So basically, the game or the simulation, let's say, have been built with GAMA. So here we have one of the first UI I designed with GAMA. And basically, the game is the player take on the role of a mayor, and he has or her has she has a bunch of action at his disposal, like changing the infrastructure, communicate around new mobilities, etc., etc. And based on those actions, he has to turn the city in 5 or 6 years into a city with sustainable mobilities. Basically, this is an ABM also. There's three main parts of this ABM. So there's the mayor, which is the player. So this is an agent and all controlled by the player, by a human being, a player. There's the household that make the decision where to go and how they go there. And there's the environment made of a city with districts, accessibility like infrastructure to go from this district to this district, etc., etc. I won't go into the detail here. It's the mobility choice process of household. So there's many aspects. There's behaviors, there's the habits. They evaluate each mode for a given path, etc., etc. I won't go into the detail. Just they have satisfaction regarding their mobility, how they are satisfied. It could be impacted by the amount of traffic jam, for instance, etc., etc. And they also have kind of an evaluation of the action of the player. So basically, the player has 3 types of action at his disposal, structural or non-structural actions, meaning that he or she can change the infrastructure of the city, like the roads, having like specific road for bikes, implementing public transport, etc., etc. But also non-structural actions like subsidies if you want to go for electric vehicles or stuff like this. So this is a negative impact on the budget, and there's also positive impact, positive or negative impact on budgets related to taxes. So you can tax the fuel, for instance, you can tax certain kind of vehicles, etc., or you can lower the tax, so you will have less budget to invest in structural changes, etc. And there's also regulation, like having an area without any cars, for instance, stuff like this. So basically, the first step was like to design this model, implement it, and I have this, let's say, good-looking UI that you see on the left part, but it becomes too complicated to manipulate and to change and to play with the model because the UI is the main part. So I get back to a more classical view on the model, let's say, to be able to play with the parameters. So basically, there were a tension between like realism of what we want to represent, like a whole city deciding how they commute, where they commute, what will be the mode for commuting, etc., and also enjoyability or playability of the model. It was quite a tension, to say the least. And after that, there's also plenty of issues regarding calibration. Like for instance, here on the right part, you can see all the aspects of decision making. Like there's the spider diagram. There is all the antecedent of decision on which mode to commute by the household. And the calibration among all those facets of decision is quite tough and quite difficult. There's also a calibration on the impact of the action of the player. Like, for instance, raising the public transport ticket by 20%, how it should change the proportion of mod use. There's also quite heavy task in calibrating the budget. And for instance, like non-structural action, like limiting the speed in downtown for cars to 40 kilometers, let's say, how much it costs to implement those kind of stuff. This is quite puzzling. Anyway, so there's plenty of aspects that we have to calibrate, that we have to take care between realism, playability, etc., etc. So this is why we turn toward another kind of game, let's say, not powered only by GAMA, but we do have the simulation, and then we build on top of it a Unity-made game. So you can see the very first prototype on the right part of the slide here. And basically, there's many challenges we are still facing right now. And the first one is how to organize everything. So basically, we do have GAMA with the simulation on the right part. We do have Unity that provide the build of the game, which is based on WebGL. And we want the player just to connect and be able to play. No installation of GAMA, no installation of nothing. So it should be ready to play, just hitting a link on a website. Okay. So basically, we take the middleware that have been built in the sample. In fact, the very first version of this middleware to be able to connect the build in WebGL with GAMA. It has been quite hell, but with the help of Patrick and the Simple team, we have been able to build something that works more or less quite well, but still there's the problematic and the big issue of putting it in a workable way for people just to plug and play. So basically we have to package everything like the simulation, the middleware and the Unity build into something that player can connect to safely, can authenticate themselves, even have an account of in the game, so they can progress in the game, etc. Do maybe many plays, etc., etc. So also we can record the decision and the plays of the player. Here is the last slide of the presentation, but I won't go really much into the detail, and I'll try to do a demo of where we are in the development process. So tedious part now is to show you how we can set up the thing. So here we do have our GAMA model. So there's the simulation. So you can see my screen and my pointer. Is it okay? Yes.
Yep.
Okay.
Oh,
Thank
yeah,
you.
can
So
see it.
we do have the simulation there. So there's many files in there. We do have a linker. So this is the 2024 10 version of GAMA, the alpha version of last month. We included the plugin, simple plugin. And then we have the middleware, which is just some GS code that we are running like this. It will open something, but it doesn't work on Safari, so don't care about this. We do have a website for our game, so so it doesn't work yet on Safari, but here on Google it works quite well. So here we do have our simulation, and then we can control the connection with the middleware here. So this is an old version of the middleware we are using, and we are tweaking it. So here I just connect to the GAMA server, and here I will connect the Unity build that is recognized automatically. So here we add the Unity build, and you can see that it started the simulation within GAMA. And here you have to play by yourself the model, and it will reflect the time. So here, this is the exact time, the same time as in the model. So we can pause, for instance, here, and you can see that the simulation is paused. And we implemented just for you, just a small feature where you can increase the time step. So here we can see that it goes it speed up quite a bit, and we can slow down, and we can see that it reflects in GAMA. So the simulation is also slowed down. So this is really an alpha version for now. We are connecting everything of the simulation to the build itself. It works quite well, to say the least. And we are still implementing few things. So you do have like the menu. We do have like plenty of stuff like this to interact with the simulation. Like for instance, here, this is just parameter of the model or variable of the model, and you can lower or higher the value of the model, etc., etc. So the idea here is really to have a more accessible way to interact with the simulation. And that's it pretty much for me. If you have any question, please feel free to ask.
Yep. Thank you very much, Kevin, and congratulations for this demo. It works well. Well, yes.
This is
Any
just a way to say that there
question
is connection. The connection is made. Yeah. Please.
Yeah, sure. And after, of course, we for the middleware part, I mean, I'm sure that we can improve this part to be have something that is more easier friendly to use for an application like yours. But so do we have a question? Specific questions?
Yeah.
Just will it be playable in
There's
VR?
Alexis.
I don't.
Okay.
Maybe Alexis.
Will it be
Question or-
playable in VR? Oh, yeah. Alexis, sorry.
No, it's just a quick question. Is it a multiplayer or only one player per game here?
No, there's only one player. There's only one mayor.
Okay.
So
Well,
only one player.
Okay, because I think that's basically it is something we are thinking about in simple, and which progressively probably will be the case, is to so that gamma is hidden in a way or another. Once the model has been calibrated, validated, etc., gamma is hidden, and it's just packaged actually with the game, so you don't see it. Okay, you just launch the game. You don't see the middleware, you don't see anything. And in your case, I'm not so sure you need the middleware because you can connect directly to the server, by the way. But I think it is something we are thinking about, both for developers in Unity, so that they don't have to, when they test, to launch the whole process and middleware, etc. But also for the players. So of course not the virtual reality, not yet at least, but probably the players like yours on WebGL. It will be much simpler to be able to package gamma.
Yeah, just concerning the use of the middleware, we were forced to use it because I don't know why exactly, but Unity build in WebGL, you cannot connect to them like through WebSocket directly from Gamma. I don't know why. To be honest, I am not. Technically, I cannot say why, but it was not possible to connect to the Unity build. Whereas the middleware, maybe it's linked to GS, I don't know. But we were able to build that. And by the end, of course, we want to package this on the server side, so there's nothing to do with it in the client side. Only hitting a link and starting to play.
Later, but it's linked to the fact that the middleware propose some specific messages to Gamma. So it's the simple toolkit was designed to use with the middleware, but it's okay. We can discuss about it later. And for a playable version in VR, I think it's very easy to pass from the WebGL to VR after, if necessary. But we have to pass to the next presentation. And thank you again for the presentation and for the demo, Kevin. But we have to pass to the next presentation. So the presentation, sorry, so of Léo Biré. Léo?
Yeah, I'm here. Thank you, Patrick. Thank you very much, Kevin, and everyone for your very interesting presentations. I'm going to share my screen. Can you hear me properly?
Yep.
Yeah, okay, great. And I hope that you can see my screen in plein écran. Great, thanks for the confirmation. So for those who don't know me yet, my name is Léo Biré. I am a geographer, a social geographer, and I'm interested in irrigation, social processes regarding how water is distributed in the Red River Delta in Vietnam, more specifically. But I'm not going to talk to you about this today. I'm going to tell you about the first results of an approach that I and my PhD supervisor, Jean-Philippe Venot, who could not make it today, I've been interesting ourselves in because there is something that happened when I was interested in when I began to be interested in participatory modeling, is that in the literature we can see that public participation is very much discussed, and modeling is very much discussed in public participation. However, in this very scattered body of literature, we don't see much of the ABM platforms. Usually ABM platforms such as GAMA are cited in a short sentence. Sometimes the implication of the use of such platforms are a bit explored, a bit explained, but the caveats of the use of such platforms are usually not explained as much. And so in my PhD, what I wanted to do as a kind of first state of the art was to propose to see ABM platforms not as neutral tools, but as agents having affordances in terms of public participations. What do ABM platforms inscribe, and what do they afford in public participation? To do that, I focused on two ABM platforms, GAMA, so it's the GAMA days, and it's the platform that I'm going to use in my PhD, and Cormas. And the reason that I am interested in those two platforms more specifically is that I have a personal and professional proximity to both those communities, and that, of course, I could add some nuances here, but the body of literature and the size of both communities can more or less be compared. Although Cormas have been suffering some slowing down for the last few years because of the slow shift to Faro. In order to try to explore the value and place and location of ABM platforms in public participation, I used two types of data. The first was to qualitatively review a few scientific articles, both exposing and explaining about case studies, so how agent-based modeling was used in public participation oriented projects, or projects that used public participation, but even though it was not planned in the beginning. And I added to these 25 case study articles the 11 theoretical articles that were published on both platforms, GAMA and Cormas, that throughout the years documented the new features of the platforms. To this first data sample, I added a qualitative analysis of a body of 11 open-ended interviews with core developers and modelers of the Cormas and GAMA platforms that have been that are involved in the development of GAMA and Cormas, or that have been involved in either like closely or less closely to participatory modeling projects. The objectives of this research is to identify and characterize where ABM platforms are located in the literature and how their role is defined in this literature, or when it's not defined, and the place that the platform hold in the developers and the modelers' representations and practices, to kind of understand that, okay, if the literature is not defining very much the place of platforms in public participation, then how do the modelers identify the role of such platforms? I can come back on the articles in the discussion if we have some time, but basically the qualitative analysis is very new for me, and the articles that I selected are more linked to projects. So I try to analyze projects rather than articles themselves, because articles alone would not make sense, or not as much as in the light of the project they inscribe in. So I would like to present a few first takeaway messages. That's not, I believe, the conclusions, the final conclusions of this research, because I just I'm just done with cleaning the interview corpus and what I also found in the literature. But there was 3 areas of interest that I wanted to submit to the community, to the GAMA community, so that we can have a first discussion on what I found that could be interesting regarding the role of ABM platforms and their location in public participation. The first thing is related to the recent evolution of both GAMA and Cormas. And this first evolution is the movement of professionalization of platform development. So both platforms began in small research groups, and as they grew and as they increased in their popularity, they specialized their skills, and they needed both GAMA and Cormas to rationalize the way that they develop in order to ensure sustainability. And this professionalization is one of the resulting factors that favored a progressive shift of both platforms from ontologies, so how it is providing a certain conceptualizing of reality, how we frame objects, okay? That was the first role in the mind of platform creators in the beginning, to operational tools. So if I use an image, because ontology is not is maybe not talking to everyone, it's at first platforms were defining delimiting objects, okay, as a painter who is interpreting reality. Okay, what does it mean? What does the object that I see means? How can I define it? And progressively, platforms began to become places where tools are available to model reality, and the ontology grew less and less important, like as regard to people who are using and developing the platform. The second area of focus is the link between how public participation is conceptualized in the community of practices of the different platform and its consequences on the development of tools. So this is something that can be seen as kind of obvious. Of course, we need different things. And so we develop different tools. And we have trends of definition of public participation, the form that it takes, its logics, its goals, that is indeed linked to what the platform is going to develop, what it's going to propose, and what it's going to afford. Cormas community is putting an emphasis on fostering dialogue, supporting figurative modeling, and the product that the platform is going to propose most of the time is going to be such as the Varza Viva visual representation that you can see. GAMA community is more emphasizing on educating for informed decision and raising awareness with the support of integrating GIS and with a will to have models that can be generic and when they can support also decision making. These two, the way that I categorize these ideas in public participation by modelers are not mutually exclusive. Of course, in both GAMA and Cormas, these fostering dialogue, supporting decision making can be found in both communities. I'm just highlighting here what in the interviews I kind of can interpret how modelers defined public participation in their view. I'm going to pass very fast on the last area of focus that seemed interesting to me. It was that indeed, and to me the most important thing, the ABM platforms are inscribing things, okay? They are, the way that we approach them is shaped by the modeling language that we use, the way that the model is instantiated, the way that we have to perceive ourselves, the agents and the world that they are going to evolve in. And this is different in both platforms, and this is inscribed in the platform. They also can afford things, they can propose and have generous constraints, such as tools to for participation that will be inclusive for the general public, like Gammagram or the executable activity diagram editor, both in Gamma for the first one and Cormas. Live coding is also a very good example of dynamic engagement for the communities that are involved in public participation. But what I found even more interesting in all my interviews, I don't think that any interviews in any interview didn't talk about this aspect. It's that the generous constraint is not located in the platform. The generous constraint is more located in the proximity that the modeler, the user of the platform, has with either the core community or someone that is close to the core community. So basically, yes, the platform is going to inscribe a bunch of things. You can't do everything with one or the other platform. And one or the other platform is having its own use. It's looking to do something. It has a niche place. But the generous constraint is that you can ask for enhancements and features way more easily when you're close to the core community. And this is the actual affordance of such platforms, and the power of such platforms is that it's their liveliness and their vivacity. So to conclude very quickly on this first overview of results that are not definitive at all, and my objective was really to begin the discussion on the few data that I can have analyzed by now, is that we can see a sliding of ABM platforms from their original purposes to define concepts and to frame them to the providing of operational modeling tools. The second thing that is interesting is that the communities of practice are actually more capital than the tool itself. The tool is carried by these communities of practice. And this community of practice, these differentiated tools allow for a differentiated use of platforms and different places in public participation that is yet to characterize more specifically. I would love to have some remarks and some intuitions that you have on these first results, and thank you very much for your attention.
Thank you very much for the presentation. I don't know if you have some question or remarks from the audience. Alexis, yep.
Yeah, I have one question. Thank you, Leo, for the presentation. Very, very interesting way for looking at platforms, actually. And I think one of the aspects which is more and more emphasized in Gamma, since we are in the Gamma days, and which has been presented by Kevin just before, is the question of the trust you can have in the models you use for public participation. Because it's so easy to introduce biases. It's so easy to introduce opinions and transform actually bias into facts, modeling facts. That's putting an emphasis on the calibration, validation, maybe transparency of the models is in my opinion something which has been quite vivid in the Gamma community, and which probably will gain more weight in the coming years, because the more we are going to use these models, the more people will need at least to trust them in a way or another if they want to use them for decision making, or maybe just for mediation or negotiation. So what's your, I don't know, what's your opinion on this, or maybe have you already considered this?
Yeah, so calibration, and there is also the aspect of exploration that came back in a few of my interviews. The fact that we sometimes use models that we don't know really what they are saying, and we need to explore them. That's a very important aspect of our work as modelers. And in order to know what the tools that we're using actually say, and what they can actually say in differentiated contexts. What you say also makes me think of what Zenith presented in the fact that we can visualize models now in very different ways. For example, in Cormas, you have the live coding, so you can have a box with your code and then show clearly that, okay, I'm changing this line. This is the result on the agent. And what Zenith shows is that you can also kind of have this, okay, I have the model on the left, and then I have my diagram on the right. And then how is this, how are these lines of code actually working? And I think this is a good way, this is a good way forward to actually gain transparency, because I have a doubt that Smalltalk, that GAML is going to be transparent enough for people that are non-modelers, but we can find ways to translate that in either a language that can, it can be different than words. It can be graphical representations of the lines that we write, but it will still always be a translation, and with translation we always lose something.
Okay, sorry, but we have to pass to the next presentation to
Thank you,
stay
Patrick.
on time.
And thank you, Alexis,
thank
for
you
the
again
question.
for the questions. Hiromitsu, it's your turn. It's okay?
Okay.
Okay, you can share your screen. Presentation. Perfect. So the floor is yours.
Can you hear me?
Yep, perfect.
Okay. Okay, I'm HATTORI, working at the Rizumaka University in Japan. This time, I'd like to talk about my ongoing development. Recently, I have tried to develop a multi-simulation-based tool for supporting policy making, policy design to be used by officers at the local government, policymakers, and to be used to persuade residents. So this is an image of our development. I believe, like the people now joining GAMA days, I believe multi-simulation is a powerful technology to support policy making design, but it's not, of course, it's not enough just to show the result of simulation. So we need stakeholder commitment. We need to collaborate with local government and policymakers and so on. So we have tried to realize participatory multi-simulation environment for inclusive policy design. Participatory simulation may enable us to make policies that stakeholders can agree on and that are more likely to be socially accepted. But on the other hand, optimal policy effects are also required. So we are also trying to construct a function to obtain optimal or near optimal solutions with multi-simulation. For our development, we have a small target problem in Japan. Near my university, there is a train station, and the reconstruction of the station and the surrounding area has been planned. During the reconstruction, traffic will be, presumably traffic will be quite heavy, so local government has considered some measures, policies. It may be possible to expect the effect of one policy or measure, but hard to do to expect the effect of the mixture of some measures. Now, also, some residents want to know what will happen in their living area, and some of them are eager to participate in the policy-making processes. So I have developed an environment to let residents understand the policy-making problem for the area and provide the officers of local government the provision of the area, deployed some measures, some policies. The system is just a prototype. Users can select policies to be deployed on iPad and find and see their effect from simulation viewers and some graph viewers. Only the currently only the simulation viewer is projected onto the table, so no CityScope function to modify the placement of buildings. So currently the system is very simple one, but at the workshop we have got some good feedbacks from people. The system is interesting. It is very interesting to get to know the effect of some policies, and it is so useful for evaluate some policies or design of communities and so on. But some people said to me that it is so hard, it's so difficult to find suitable or good or optimal solution by themselves with this system. So in this system, they can change the deployed policies and get effect, but they cannot know what choice is effective, what choice is good for the communities at this moment. So so we must think about how to help such a situation. So next, we try to realize the function to find optimal or near optimal solution, which can work with simulation based on GAMA. To do that, I applied job management middleware, OASIS. It is developed at the National Laboratory in Japan. With OASIS, we can run so many simulations in parallel. So we can conduct optimization based on the, for example, genetic algorithm using simulation to evaluate parameter set during the process of genetic algorithms. So we conducted experiment with over 5,000 normal vehicles and about 40 buses. Bus agent. By changing parameters in genetic algorithm, the combination of policies and control parameters of some traffic light can be modified to achieve optimization of the average speed of vehicles and the punctuality of buses. As shown in the movie, in the worst case, sometimes long queue, the red dot represent one vehicle. So in the worst case, sometimes there is a long queue, so long red line. But at the best case, it is rare to see the very long queue. So there are same number of vehicles, but at the best scenario, best case, the vehicles are always running, so the average speed is very good, and the buses can stick to the scheduled time. So by using the OASIS, using the combination of OASIS and the gamma-based simulation, we can find the near optimal solution in a also, yeah, as shown in the graph, it can be observed that as generations the genetic algorithm process, a solution is obtained that maximizes average speed of normal vehicles while minimizing bus delays. So the developer function can provide a good solution, but the computer-generated autonomous solutions are not always practical and may not always be accepted by people. So what is our next step? So now we will try to complete the development to combine computer-based optimization with human perspective-based evaluation through the participation to the machine simulation processes. In the extended system, users can see computer-generated autonomous solutions and evaluate them. If they are not good or practical one, from a human's viewpoint of the value, they try to search practical neighbors of computer-generated solution. So we can get practical optimal solution by the participation of stakeholders and the power of AI technology. We plan to conduct the social experiment in early 2025. So hopefully I can get a good result and I can report the result at the next GAMA days. Okay, that's it. Thank you very much.
Thank you very much for your presentation. So do you have, if someone has some questions? Just for me, I just have one question. I have one question about, did you consider that people, when they are choosing their path to go from one point to another, they are choosing the shortest path, or they can take into account the traffic jam to avoid some specific roads and so on?
For the bus, the bus just run the
for the normal vehicles.
A normal vehicle. Basically, they try to find the path, the shortest path at the early stages, but they try to find the better passes, which can shorten the travel time.
Okay. I don't know if someone has questions. I don't see it rising. You can raise your hand if you have another question. Not up. And just to know for the simulation in terms of computation times, how long it takes to make one simulations with your model?
Actually, this simulation is not so the big one. So for one simulation, it takes I can remember the detailed time, but 10 or around 10 minutes for 1 day simulation.
Okay, and is it a stochastic, or did you have to do some replication of the same simulation to compute the, the average, for instance, result in terms of travel time or speed of vehicles and so on, or is it not stochastic? For me, it's just an idea of the optimization problem. Is it stochastic? If you repeat twice the same simulation, do you have a different result, or do you get exactly the same result?
Not the exactly same result come. There's some each time we can get the different result from the simulation.
Okay.
There are some random elements.
Okay. So so you have to repeat several times simulation to get the robust result for your optimization. Yep. Okay. So if we have no question, we can pass now to the next presentation. Thank you again for your presentation, and we can pass to the next presentation. So it will be a presentation. Sorry, up. So it will be the presentation of Bruno. If you are here, Bruno. We can start the presentation.
Okay, so hi everyone. My name is Bruno Dato and I'm working at IRIT in France, Toulouse. And I'm going to present you the state of our multimodal traffic simulation and how we are thinking to make it more generic and to especially make generic scenarios to apply to other use cases. So the project in which I am is focused about different axes. There is the agent-based simulation, where we simulate the traffic in a small industrial area. And we use the simulation to generate data so that it can be replayed using Unity. But now that we have discovered Simple, we also use the simulation to stream it in a 3D environment. And the final goal of that being to be able to interact with the simulation so that non-expert users could set a simulation and modify its parameter files, because today we have a lot of parameter files, which some are ad hoc, which means they are specific to the use case we are on. And the goal is the final goal being to add a generic editor that can be used in augmented reality or VR, so that we can dispose a new area and make new urban plans or test different scenarios without being an expert on GAMA. So basically, a scenario is composed of geographical data, transport data, driving data. So you can see here that we are modeling low-level interactions between all the agents, and we go from vehicles to the pedestrians and the passengers. And we choose in our simulation to represent the agents with flows and their distributions, meaning when they enter in a zone, we have to know where they're going to leave the simulation. And we have also a bunch of manual data that I will present some. So concerning the daily flows, the zone we are working on is an industrial zone where many companies will be present in the future years. So we dispose of a study of urbanists that provided us detailed data on rush hours. And this detailed data allows us to make manually distribution matrices to know the routes of the flows in this zone. And we have also detailed counting data, but only on 3 points of our industrial zone. So we are able to generate histograms during the day, but only in some points of the zone. So we had to make a little bit of linear algebra to extrapolate the data of the flows on a full day. And thanks to this rush hours data and counting data, we are able to estimate the incoming and outgoing flows in our simulation. But we still have to make some weight estimation between the morning distributions that we have and the evening distributions. And thanks to that, we are able to recreate the flow of the flow that was measured by the urbanists. And then, thanks to the prospective studies that they made, we are also doing prospective flows. So what you can see in the animation, the blue vehicles being the actual flow present in the area, and the white and the red and the yellow being the prospective flow. So we can and we do that to test the prospective scenarios. However, this approach is quite has a bad generosity because it depends on the area. So when we are now that we are thinking on how to generalize our approach, we think we will be more focused on calibrations calibrations from the counting data if we want to apply it to other areas. And then concerning the geographical data, we use OSM data to create the network on GAMA, which is done using the driving skill plugin. And for the transport data, we use GTFS data, and we use it only for the timetables because we noticed that maybe it's an issue only for the Toulouse region in France, but the OSM and the GTFS route shapes for the transport are different. So if we want to have a coherent network, we are forced to only use the timetables of the GTFS data. And thanks to that, we are able to model our flows until with the details of passenger drops. So I don't know if I said it, but our simulation being focused on multi-modalities, our flows can be set with a percentage of people using the cars, people using transports or bicycles. And we are now testing this generation of the world on other areas, and we are pretty much to the full genericity of the world creation, except for the bus routes, because depending on the area that we choose, some routes can be cut, and we have still further work to do to achieve full genericity. And then I will present you here an example of some urban planning that we are doing on the zone. For example, the urbanist proposed a new crossroad in some zone of our area, and today we are not able to modify it directly from the GAMA simulation. So we use an external tool to modify the roads, and then to add the traffic signals. As there are no database concerning the traffic signals, we have to edit the roads and add manually each traffic signal and its phases. So this is a work that is complicated to do directly in the GAMA platform. And such as adding parkings, it has to be manually. So we are thinking now of what I said at the first of the presentation, to use an editor for our scenarios. And for our editor, we are thinking of exploring how we could do it with the tool Simple, because it allows us to have a 3D scene that could be played with with a screen like a video game, but also with VR, which is more easy to use for non-expert users. And we will be exploring how to play with the histograms of the flow, and how to modify the flows or add flows directly from the simple scene, but also the distributions, and also adding the manual data so that we can add parkings or also modify crossroads directly in the 3D scene, and also add the traffic lights or special events like accidents or works on the road. So here's an example of the view that we can have in using Simple from our GAMA model. You can see that it has the vehicles, pedestrians in blue, bicycles, and here comes a bus that will drop some passengers. Thank you for your attention.
Thank you very much. Yep, sorry. Thank you very much for your presentation. So we have one question. This is how do you build your prospective scenarios and assess their impact in the system? It's by Franck.
You said how do the prospective scenarios are built by the urbanists. They made estimations of how much people will come to the zone in 2025, 2030. And we have also the estimations of the percentage of flow that will come from each incoming flow of our zone. So that's how we create them. And we have the percentage of people using the cars and bicycles or transports. And what was the second part of the question?
How do you assess the impact in the system?
Sorry, I didn't assess the impact. Okay, yes. We have a matrix of congestion on the roads. To first, we have different urban planning changes that we can add, and we calculate which impact on the jam it will have if we had a new road, or if we increase the size of a crossroad, increase the lanes, for example. And
so is that okay?
How you thought about benefits?
Yep, for the VR, what is the benefit of VR for your?
The VR benefits, to my opinion, it's to have a better comprehension of the world in 3D, and to the gestion of flows when we use it by hour and by interactions. It can be really painful to do it in a 2D user interface. So it could help to play with the histograms directly in VR. So it's just an example. And also drawing new urban plannings directly in VR could be helpful and be easier to do it than in the tool I'm using, which is hard to understand and not really ergonomic. I don't know if this is the right word in English.
Two questions a bit linked about computation time. What is the computation time of your model, and what is the time step and the population sample? First question. And second question is same. How many cars are you able to create to this level of fluidity?
So to run an entire day, it lasts around 5 hours. And on an entire day, there are like 40,000 vehicle flows that pass through the roads. And the problem with the population sample is, like, we are not considering an entire city. We don't know who is coming in, who is passing through the zone. We only know the numbers that are passing. So this is why we are using flows and not agendas like we usually do in some this kind of simulations. So concerning the population, it's hard to understand which to which population corresponds a vehicle that is passing.
Okay, so we have to stop now and to pass to the next presentation. Thank you again for your presentation and for the answer to the questions. And we are going to now pass to the next presentation of Indrafo, if you are here, Indrafo.
Let me introduce myself before. I am Mohamed. I am from Madagascar at the University of Fianarantsoa. I will present about automatic generation of thematic maps using multi-agent system. This is the plan. Here is the plan for this presentation. Let's start with the context. The sustainability management of renewable resources is a key factor in ensuring the equilibrium of our planet. Forests are one of these renewable resources. However, they are undergoing rapid change as a result of social dynamic and constantly evolving process. In order to monitor and understand this transformation, the thematic maps are an indispensable tool. But what exactly is meant by a thematic map? Thematic maps show the spatial distribution of particular phenomena. In our case, they enable to visualize and analyze the change affecting forest ecosystem in order to gain a deep understanding of dynamic at play in their sustainable preservation. Although thematic maps are extremely useful, the slow of production process is particular challenge for organization. Moreover, the lack of reliable predictive data limit the ability to produce forward-looking thematic maps. In addition, we can't afford to wait for a year of field observation to get an update view of the state of our forest. However, major and irreversible change may occur. That's why our main objective is to predict the evolution of phenomena in advance throughout the creation of dynamic and evolving thematic maps, which designed to faithfully reflect reality and respect the standard of digital cartography. We identify several categories of approach for generating thematic maps. For example, the traditional method you use GIS software such as QGIS. Another semi-automatic approach using web mapping. In addition, the use of package like R or Python. There are several approaches to map prediction, like cellular automata. They are a jump-based approach and artificial intelligence-based approach use advanced algorithms. This approach has its own advantage and disadvantage. For example, the traditional method, which is simple to implement. However, the data for the future does not exist for the predictive thematic maps. As for us, the map prediction is concerned mathematical models such as cellular automata, accurate. Nevertheless, they may lack of flexibility in face of unforcedness phenomenon. So to assess this objective, we have developed a methodology based on several stages. The methodology begins with the identification of the study area and the core of study is then based on the multi-agent system using a classified satellite image obtained via remote sensing as a simulation environment. We also integrate GIS vector data to delimit the various administrative zones and initialize the simulation parameter with the attribute data. Finally, a computer model based on the field study enable us to simulate a realistic environment where agent behavior and territorial dynamic involved. This combination enable to generate involving thematic maps. The remote sensing need a pre-processing and classification. For the GIS, we need a data acquisition and different pre-treatment. For the modeling, we use RD method for the modelization to identify actor, resources, the dynamic and interaction. Finally, the core of the study is multi-agent system. For this, we will use the satellite image classifier to initialize the simulation environment. This will be followed by the use of vector data to define the initialization parameter and boundary of various geographical objects. Finally, the use of a computer model translate into computer code implement the dynamic and the behavior of agent and their interaction with the environment. For the implementation, we are use GAMA for the simulation, Google Earth Engine for the classification, and QGIS for the vector data treatment, Python for the validation, and this is our architecture. For the experiment, we use Landsat for the image satellite and data for the district of Batu in Madagascar in 20 and 28. Yeah, the constant timestamp is used for the simulation, and one time step represent 1 month in the reality. The result is a multi-variety of thematic maps generation tool that represent the evolution of forest cover in the district up to 20 and 38, following the digital mapping standard like this video show. There are a chart to the decision and the result of thematic maps. The result also enable to answer the question posed on the model, and we obtain that the district lost around 21% of its forest cover between 20 and 18 and 20 and 38. Another strong point is the result is the generation of 3D thematic map offering a better visualization of forest cover evolution. For the validation, we compare the result of thematic maps obtained via the simulation in 20 and 23 with a real image in the same date. For conclusion, GAMA offers a possibility to generate thematic maps it is we can apply it in the various areas like urbanization, for example. At the moment, the study have some limitation, but we can explore it to the future research. Thank you for listening. I am available for all questions.
Thank you very much for your presentation. I don't know if there is some questions in the audience.
Yeah, I have one. Sorry. I have a
you can,
question. Yeah, so thank you very much for your presentation. It's very, very nice and interesting to see these works being done. I'm just wondering about the users of who are and who will be the users of your models. I mean, is it intended to be used only by scientists, or are you going to try to put them in the hands of non-scientists?
Okay, the user of this model are the who take the decision, like the minister or person who take decision in the, for example, in the national parks, and the people in local for have idea about their forest evolution. For example, the person who take a decision.
But do you think that you can just put the model like this in their hands, or do they need to work with you to explore the different scenarios and explore the different parameters of the model?
It is everyone can use this model because there are many parameters to manipulate, and everyone who has this model can manipulate if they have a notion about IT, for example.
Okay.
So we can give it for everyone who know a notion about the manipulation of computer.
Okay. Thank you very much.
So Franck, the same question. So I just have one question about, are you taking into account the work on graphical semiology for your map? Because there's a lot of been done to have maps that are readable and easy to understand by people. Are you taking this kind of work into account?
Can you repeat again your question, because I don't understand?
Yeah, because in cartography, there's a lot of work have been done about semiology, so how to represent things in order to be readable and easily understood by people. So are you using this type of work for your own map that you are generating with your model?
Yeah. Yes. For example, on the result of simulation, the map have a norm of a standard of thematics. It has a title, a legend, and everything standard. Is it répond à your question? Do you want to...
Okay. No, it's okay. It's okay. So just to have some ideas. So thank you very much for your presentation. We have to pass to the last presentation of the day from Gamaliel, if you are here.
Yeah, hello everyone. My name is Gamaliel. First of all, I would like to thank you for this opportunity to present some of the projects that we have been working on at the City Science Laboratory at Guadalajara. For these projects, we use ABMs and the GAMA platform. I would like to introduce to you this amazing team. This is a serious science lab, which is at the University of Guadalajara. This is an interdisciplinary team focused on basic and applied sciences. The lab focuses on research for the development of emerging technologies to enable the understanding of human behavior in urban environments and the design of sustainable communities. Recently, the laboratory has been working on the development of Citiscope Guadalajara, which is a tool for analysis of the development of the University Cultural District, which we can aim to enable diverse functional district with the objective of obtaining the lowest environmental impact possible. So in this first part, I will walk you through our methodology, how we model this project, and also how we visualize while also discussing some of the proposal of the indicators. So yeah, the first step was to identify indicators related to what we found are the three main axes previously mentioned in the research question. So each indicator of model defines a quantitatively a normalized value that can be used for the measurement of the performance of the current scenario. Using that classification, we created or we proposed a hierarchical ABM that allowed us to represent each element of the infrastructure relevant to the indicator. So the model in this way has been designed in such a way that when a change is made in the environment, an event that is programmed in the GAMA script, an event updates the value of the corresponding indicators, taking into account the recent changes in the infrastructure. So this approach enables the interaction between the agent's model and the tangible user interface. So yeah, changes in the environment are detected through a computer vision script using Aruka codes. This information is then sent as a change signal. So we designed some kind of information packages in order to be sent to the GAMA platform. So we enabled some communication ports there in the GAMA file. With that, the GAMA model receives that information and recomputes the indicator values and sends the result, the updated values. The results are sent to the dashboard. So we designed a dashboard with the different variables interest for this scenario, and also it updates a set of heat maps that are displayed on a screen below the tangible green pieces. So with this implementation, or with this approach, the Citiscope has been used on multiple applications so that stakeholders can observe the impact of the decisions in different dimensions or variables. It has been very useful for the other different projects that are involved designing new interventions in the University Cultural District. In addition, the project has been presented at multiple education and technological innovation events here in Mexico. The second project that involves the use of GAMA platform is the University Community Safety Project. In this case, the laboratory collaborates with the General Coordination of Security of the university to identify solutions to problems and also to challenges related to the security of the university community, studying aspects related to the environment and urban factors. In this project, the objective is to design simulation models to different scenarios with different configurations of the urban environment and show the possible impact of the occurrence of crimes such as robbery and harassment. This comes from the fact that currently the university has enrolled around 300K students distributed into more than 10 campuses along the whole state of Jalisco here in Mexico. So this represents a very unique scenario to study. The first step that we always do is to identify and study the different factors involved in the phenomenon. So during during this modeling step, we identify a number of theories from the social sciences that explain criminal behaviors. And we have found that the most relevant are the crime prevention through environmental design, SIPTED, also the environmental criminology and the theory activities. All those theories have in common that they characterize criminal behavior as the result of a decision-making process performed by individuals. So we use that information to propose an agent-based model of criminals where each agent perceives the environment looking for important variables such as the presence of other people that could watch the possible result. Also, it is important for the criminal the quantity of light, police patrols nearby, and the observed maintenance of the street. This is also related to the broken windows theory that some of you might know. For now, we distinguish between two simulation scenarios. So we try to put here a video, but for some reason that media didn't work. So I'm just putting a couple of pictures here. We are interested in knowing two scenarios. We want to know the criminality rate in the vicinity of the university campus in cases of high and low rates of punishment of criminals. So we are simulating scenarios where criminals or criminal behaviors are highly punished, as well as the other scenario with moderate and zero presence of police patrols. So we want to distinguish that in a first step. Then we will proceed to introduce more environmental variables. The last project that we're working on, and I want to share with you, is the ABM for flooding risk assessment. For this project, we collaborate with IMEPLAN, which is the Metropolitan Institute for Planning. We aim to study the possible consequences of carrying out urban developments proposing protected ecological zones. Through the literature review, we identified two phenomena that result from the soil waterproofing. So that is the first variable we are interested in, the waterproofing soil. And this happens due to the urban expansion in the protected area of the Bosque de la Primavera, or the Primavera Forest here in Guadalajara, Mexico. And we identified two different phenomena that arise from that urban expansion. The first one is the reduction of the recharge of the aquifers, which leads to water shortage in more than 300 districts in the metropolitan area. And the second problem is the increase in the risk of flooding caused by accumulation of water. That is water that does not filter into the aquifer. So we proposed a flooding simulation using ABM that receives as input the details of elevation through an DEM file. And also we use as input the buildings and well-proof soil, as well as the data of the quantity of rain in the Primavera forest. And as a result, it is intended to obtain an estimate of the risks of flooding in surrounding areas. Also, we want to know the impact of the recharge of the aquifers, as well as the consequences in aspects such as mobility caused by the flooding problems. This is an ongoing problem, an ongoing work. It is under development right now, and the next step is to simulate 2 scenarios of flooding. The first one is a scenario with high rainfall and low waterproofing soil, and the second one with a high waterproof. So we want to compare that and see what are the impact of the waterproofing of the soil on the risk of flooding in the surrounding areas of the Bosque de la Primavera. That's pretty much it. As kind of conclusion, I just want to let you know that the City Science Laboratory, we are working on different projects, and some of those projects are related to simulation using GAMA platform, and also as a part of the laboratory activities, we participated in a master's degree program in city science where we covered a full course in GAMA platform. So I'm in charge of that course, and we have a lot of wonderful students in 3 different groups that are working on their thesis projects using, in part, the GAMA platform for their simulations. I think that's it. What I wanted to share with you, and I'm open to questions. Thank you.
Thank you very much for your presentation. So we have a first set of questions. So about the first model that you present was how does the physical interface works? What can you modify in the interface and how it works?
Yeah. For the current state of the Cityscope, we designed 2 configurations of the infrastructure, so the user can choose different buildings, and those buildings have a preloaded set of data that is introduced to the GAMA model, and then the GAMA model recomputes that indicators. But we're working on a tiered scenario in which the buildings are not pre-built, so the user is intended to design their own building characteristics. So the objective is the user to introduce or to enter the distribution of the buildings and the land use for that. And with that information, the model transparently recomputes the indicator. So that is the way we link the physical layer with the GAMA model.
Okay, thank you very much. And for the last model, how is the flooding simulated? Do you have a model of flooding in GAMA, or are you using another software
directly? It is directly simulated using GAMA. All these 3 models are completely implemented using GAMA platform. So for the flooding model, we use actually a model that is already in the I don't remember if it's in the toy models here in the platform, where they show how to simulate the behavior of water through different soil scenarios using DEM data. So we use that as a base, and of course we use our own data about the elevation model of our case study, but actually, yeah, that's what we do. We use that model as a base, and everything is done to a gamma model.
And the last question about the second model, did you validate about criminality? Did you validate it, or do you have data about
Not yet. Yeah, not yet, because sometimes this kind of data is kind of difficult to obtain, particularly here in the context of Mexico. But that's why we are collaborating with the authorities of the university. They have a lot of data that comes from the students that every time a situation of this happens, a student makes a call, and that kind of data is recorded, and we use that, we intend to use that kind of data to validate the model. But we have observed until now that the patterns or the areas that we see in the simulation are actually the same high crime rate areas that are identified in the real scenarios. But we need to compare data by data that results. But yeah, we are on that right now, actually.
Okay, thank you very much for your answer. So it's the end of this session. So Arnaud, do you want to say something?
It was a great session. Thank you, Patrick, for chairman. Thank you, everyone. One quick note about the last talk, Gamaliel. I know it will be very early for you, but in session 5 on Friday, we will have also a talk about flood simulation in Vietnam. So that's maybe something you can attend or check later, because I think it will be very early for you in Mexico. So no, thank you, everyone. I don't have anything else to add. Really don't hesitate to participate more, even if maybe the Zoom format is not the best one. But yeah, no, thank you for this session. I don't know if anyone wants to add something before to start your day, continue your day, or finish your day, depending on where you are. Bye-bye. See you tomorrow.